Hello and welcome. Today we are looking at the capacitance probe. And we are going to look at it inside our tank here, and we are going to bring it out to a 420 milliamp loop. So we know that the capacitance probe works off capacity. Capacitance. And it works on the fact that it can go from the capacitance probe to the outer wall of the tank, or it can go from the bottom of the capacitance probe up to wherever the water level goes up onto the capacitance probe. A capacitance probe is a certain length of probe, and as the water increases on it, it changes the dielectric material around the probe, which changes the capacitance. And based on the capacitance, we can tell the water level. One of the downsides to the capacitance probe is water splashes onto the probe, and it of course changes the dielectric material, which changes the reading. And so it doesn't like to have water splashing. And in this system that we have here, water does splash. So sometimes you have to wait for a little while and let the water level out, steady out. Now, currently we are sitting at the 0 mark. We're going to take a little bit of a closer look. So here we can see that the capacitance probe is this white probe that goes all the way up, and here it hits stainless steel, and then it goes up to its head up here. Now, whenever you see it go from its dielectric, or sorry, not dielectric, it's a conductive material into stainless steel, you know that that's the full span of the unit. So from here down to the bottom, which is right here, and that's where our water level currently is, that is our full span that we could ever possibly do with this probe. We can't go more than that. We can go less than that, but we can't go more than that. We can change the 0 in span if we come up to the top of the probe and we actually have a 0 in span up here. But right now it's currently set up to do what we want it to do. So we're going to check out exactly what it's doing and how it's doing. So currently this is at 0%. And we are currently at 4.3. We see that? That is not the nicest. 4.378 milliamps. So we're just a hair above the 0. Now this is a linear device. So if we go up to 50%, which should be right there, that should give us 12 milliamp output. So let's try that. Let's start up our variable frequency pump, and we're going to drive this up. Now you see all the splashing of the water. So that is not good for an accurate, fast reading of the probe. So we're going to go up a little bit higher than that. Okay, so we're very close to the 12 mark, a hair above, but you see that it's at 12.3 and it's moving down. The reason why it's moving down is because some water splashed up on it, and now as the water drips off of it, it goes, oh, I'm not quite that high, I'm a little bit less. That's why it doesn't like splashing. Okay, so now we're at 50%. We have a 50% output, 420 milliamp. Now we're going to go up to 100%. Now, we're just a hair low. I don't want to go above it. And I'm very close to above it. Actually, I am right on. That is 19.96. So we are right at the upper end, and we are right at the top, right before we turn to the metal, to the stainless steel. So we know that we've hit that bang on. We have full range of that capacitance probe. This is how we check it, and if we wanted to change the 0 span, we could do it up there. This one is not a smart device, so we cannot hook up a heart communicator to it. but we can still do a manual calibration on it if we so desire, and we can, if a person wants to, get a smart one. So this is the capacitance probe. Thanks for watching.